One of my favorite guitar solos is the one in the Hotel California by the Eagles. Now, you could play it on an acoustic, you could play it on a classical even, it just wouldn't really have the same effect as it would on an electric guitar. But other than the fact that an electric guitar looks and sounds cool, a lot of people don't actually understand how it works. Hi, my name is Callum, and in this video, I'm going to be talking about how an electric guitar actually functions. Now, the way an electric guitar actually transmits its sound lies in these two boxes right here. These are known as pickups. Now, a very common misconception is that these pickups function as microphones. If that were the case, then just as when I play the string and it's amplified through my amp, then I should also be able to speak into it and my voice should be amplified, but it's not. So the question is, how does the pickup actually differentiate between what it should amplify and what it shouldn't amplify? Now, the short answer is the pickup isn't differentiating between sounds by any means. In fact, it's only capable of picking up vibrations from the strings in the first place. And so here I've kind of depicted pretty much what a pickup looks like. And you'll notice that there are 6 magnets. These black dots represent magnets. And over the magnets run the strings, if you recall. And so the way that the pickup actually works is it detects when these strings vibrate and then it sends electrical signals. But how does that actually work? So here we've kind of taken one of the magnets and zoomed it in and taking kind of a side view of it. So underneath these magnets, we have a kind of wound up piece of copper wire. Remember, copper is conductive, and here I'll draw in the string above it. So here would be our string. And so what's important to remember is that these strings are made of metal. So when you're talking to people, or if you've ever picked up a guitar and you tried to play, you'll notice that before you start to develop calluses on your fingertips, it does hurt to play because you're literally pressing metal wires into a block of wood. So it's important that we note that this string is metal because when we have a magnet and we have metal, we're going to get some kind of interaction between that via magnetic field. I'm not exactly sure what that magnetic field would look like. I assume it's going to be something like this. And then obviously kind of coming out of the page and into the magnet here. Something like that. Bottom line is we're going to have a influence from this string. If it moves, it will change what this magnetic field looks like. And so that right there is very important. When we have a distortion in a magnetic field and we have current conducting material, a EMF is produced. Now the equation that models that is this right here. We have epsilon, which is the Greek letter used to symbolize the EMF or voltage, is equal to the number of coils there are times the delta magnetic flux. For some reason, instead of writing an M for magnetic, we write a B, not sure why. And then this is phi, the capital letter phi for Greek to symbolize flux, over the delta T. Delta T. And so what this equation is essentially saying is that when we move and manipulate the magnetic field, we cause current to simply start moving in this wire, just almost as if it's out of nowhere. When we manipulate the string, when it vibrates like so, there is a current that is induced in this coil that directly corresponds to the frequency and degree at which the string is vibrating. Let's say we vibrate the string a lot, then there would be a lot of current flowing through, or vice versa. Now, the cool thing about this, once again, is we don't actually know why it happens. We don't know why a distortion or a change in the magnetic field induces an EMF, in turn inducing a current. Nobody really knows why, so maybe one of you guys will be the first to figure that out. But bottom line is, once we have these signals traveling through this copper wire due to the distortions in the magnetic field, now we have actual electrical signals that we can work with and then feed into our guitar amp. Another thing I wanted to make note of is, just as I was talking about speakers in another video, it uses the same principle where we have a magnetic, something to do with magnets, influencing electric current. And so that's something you're going to see throughout all electronics. It's such a simple observation that we've made, that a change in magnetic field causes current to flow, yet it can be used in so many different ways. But that's all a pickup actually is. It's not a microphone. Instead, it's a device that can translate the physical vibrations of the string into electrical signals that directly correspond with the frequency and amplitude of the vibrations of the string, in turn giving us kind of a code that we can send off to our amp so that the sound can be amplified properly. I really hope this video has given you a basic understanding of how electric guitars actually work, as well as a newfound appreciation for all the awesome electric guitar solos that you hear. Again, if you guys have any questions, I urge you guys to leave them in the comments or look them up yourselves and keep learning.